Hey everyone, and welcome back for another deep dive. Today, we're going to be tackling AI agents.
Oh, yeah.
You know, the things that are driving our self-driving cars, making split-second decisions in video games, and even popping up in your social media feeds.
What's really cool is that they're doing more than just following instructions.
Right.
They're learning, adapting, and even making decisions on the fly in unpredictable environments.
Yeah, that's kind of what has me curious. It's almost like they're thinking.
Yeah.
But how does an AI actually think through a problem?
Well, it all comes down to search.
Okay.
For an AI to solve a problem, it needs to search through a huge landscape of possibilities to find the best solution.
So, like, when I'm trying to find the quickest route through a city with thousands of roads,
That's exactly the kind of challenge AI is tackling.
so it's like me trying to find my keys. Except instead of my apartment, the AI is navigating a massive network of possibilities.
Exactly.
Yeah.
And just like there are different ways to search for your keys,
Yeah.
systematically checking every room or retracing your steps or asking someone for help,
Right.
there are different ways for AI to search for solutions.
Okay, I'm starting to get the picture.
Yeah,
So before we dive into the different types of search AI uses, maybe we should understand the world these AI agents operate in.
absolutely. The environment an AI agent operates in has a huge impact on how it searches for solutions.
Hmm.
We call this the agent environment.
Okay.
You can think of it as like the playing field for the AI, and these playing fields can vary wildly.
So an AI driving a car would have a very different environment than an AI playing chess.
Precisely. And to understand how these environments shape an AI's thinking, we need to break down some key characteristics.
Okay.
Let's start with one that might sound familiar: observable versus partially observable.
Okay, so if I'm picturing this right, an observable environment is like a chessboard where you can see everything.
Yes.
While a partially observable environment is more like a poker game where you have hidden information.
You're exactly right. Chess is a great example of a fully observable environment. All the pieces are visible, the rules are clear, and there's no hidden information.
Gotcha.
But in a poker game, you only see your own cards.
Right.
The other player's hands are hidden, making it a partially observable environment.
So in a poker game, the AI would have to make decisions based on incomplete information that sounds way more challenging. Does this kind of uncertainty play a big role in how the AI searches for solutions?
Absolutely. It adds a whole layer of complexity. Think about it. In chess, the AI can plan its moves with complete knowledge of the board. But in poker,
Right.
it has to consider all the possible hands its opponents might have, making the search for the best move much more intricate.
Wow, that's fascinating. So just this one characteristic, observable versus partially observable,
Right.
can drastically change the way an AI approaches problem solving.
It's a great illustration of how the environment shapes the AI's thinking. Let's look at another characteristic that can make things even more unpredictable: deterministic versus stochastic environments.
Okay, those words sound a bit intimidating. Can you break them down for me?
Think of it like this: in a deterministic environment, every action has a predictable and certain outcome. It's like a game of tic-tac-toe. You know exactly what will happen based on your move.
So if I'm understanding this correctly, in a deterministic environment, the AI could plan its moves with complete certainty because it knows how the environment will react.
Exactly. There's no element of surprise. But stochastic environments are a different story. These environments involve randomness, making outcomes uncertain. Think of a self-driving car navigating a busy city street.
Oh, I see. A pedestrian could suddenly jaywalk a car, could swerve into your lane, or a traffic light could malfunction. There's no way to predict everything that could happen.
That's a perfect example. Stochastic environments are full of those unpredictable elements, making it much harder for the AI to plan ahead with absolute certainty.
So in this case, the AI would need to search for solutions that are adaptable and can handle unexpected changes.
Exactly. It needs to be able to react and adjust its search based on new information and unpredictable events. That's where things get really interesting.
This is mind-blowing. Just thinking about how AI needs to adapt to all those unpredictable elements in a stochastic environment has me feeling a little overwhelmed. It's a good thing we have AI to handle this, right?
That's right. AI is well suited for navigating these complexities. And to do so, it relies on something called search algorithms. These algorithms provide a systematic way for the AI to explore different possibilities and find the best solution, even in the face of uncertainty.
Okay, search algorithms. It feels like we're getting to the heart of how AI actually thinks. Can you give me a simple way to understand what a search algorithm does?
Imagine you're playing a maze game on your phone.
Okay.
You're trying to guide a character through a complex maze looking for the exit.
Okay.
A search algorithm is like a set of rules you can follow to explore the maze systematically and find the best path to the exit.
So instead of just randomly trying different paths and hoping for the best, the AI uses a search algorithm to explore the maze intelligently.
Exactly. And just like there are different strategies you might use to solve a maze, maybe you always turn left or you look for the path with the fewest dead ends,
Right.
there are different types of search algorithms AI can use.
That's interesting. So, what are some of the different types of search algorithms? Is there a go to algorithm that AI always uses?
It really depends on the problem and the environment the AI is operating in. But generally speaking, search algorithms can be grouped into two main categories: uninformed search and informed search.
Uninformed and informed. Those sound intriguing. What's the difference?
Think of uninformed search as exploring that maze with a blindfold on.
Okay.
You have no prior knowledge of the maze's layout, so you have to systematically check every path until you find the exit. It's also called blind search.
That sounds pretty inefficient. How can an AI be effective if it's searching blindly?
You'd be surprised. Uninformed search can be surprisingly effective, especially when the problem is relatively simple or when you have a lot of computing power to throw at it.
Okay, so even without any prior knowledge, an AI can still find solutions by systematically exploring all the possibilities.
Exactly. And there's some classic uninformed search algorithms that are quite powerful. One of them is called breadth first search, or BFS.
BFS, I remember we touched on that earlier when we talked about social networks. How does BFS work in a maze?
Well, imagine you're at the starting point of the maze. BFS would explore all the paths that are one step away from the start. Then it would explore all the paths that are 2 steps away, then 3 steps away, and so on, until it finds the exit.
So it's like expanding outward in concentric circles, checking every possible path at each level before moving to the next level.
Precisely. And here's something really cool about BFS. In an unweighted maze, where every path has the same cost, BFS is guaranteed to find the shortest path to the exit.
Wait, so even though it's searching blindly, BFS can still find the most efficient solution. That's pretty amazing. I can see how that would be useful for things like finding the shortest route on a map.
You got it. And that's why BFS is so widely used in applications like GPS navigation. When your GPS is calculating the quickest route, it's often using a variation of BFS to explore the road network and find the shortest path to your destination.
That makes so much sense. I never realized BFS was working behind the scenes like that. So that's uninformed search. What about informed search? You mentioned it uses some kind of additional information, right?
Exactly. Informed search, also known as heuristic search, uses additional information or hints to guide the search process and make it more efficient.
So it's like having a map of the maze or some clues about where the exit might be.
That's a great analogy. Think of it like this. If you're trying to find a specific restaurant in a city, you wouldn't just wander around randomly. You might use a map, ask for directions, or look for landmarks that could point you in the right direction. These are all forms of heuristics, rules of thumb that can help you make smarter decisions and find your goal more quickly.
So instead of blindly exploring every possibility, informed search algorithms use these heuristics to focus on the most promising paths.
Exactly. And that can make a huge difference in terms of efficiency, especially in complex environments. One of the most famous informed search algorithms is called a search.
A search. That sounds familiar. I think I've heard of it in the context of video games.
And that's right. A search is widely used in game AI to help non-player characters navigate complex environments and make intelligent decisions.
So when I'm playing a video game and those enemy characters seem to find me no matter where I hide, it's probably because they're using a search to track me down.
You got it. A search is really good at finding the most efficient path in complex environments, taking into account things like distance obstacles and even the estimated cost of reaching the goal.
That's incredible. It's like the AI is thinking strategically, weighing different options and choosing the best path based on all the available information. It's almost human-like.
That's the fascinating thing about AI search algorithms. They provide a glimpse into how machines can mimic human problem-solving and decision-making processes. And the more we understand these algorithms, the better equipped we'll be to develop even more sophisticated and intelligent AI systems in the future.
This is all so fascinating. We've gone from AI agents driving cars to robots navigating mazes to video game characters hunting us down. It's amazing to see how these seemingly simple concepts can have such powerful applications.
And that's just the tip of the iceberg. The world of AI search algorithms is vast and constantly evolving, but understanding the basics, like the difference between uninformed and informed search and how these algorithms work, gives you a foundation for exploring further.
You've given us a lot to think about. I'm starting to see the world in a whole new light, noticing AI at work everywhere I look, and I'm definitely feeling a lot more informed about how these AI agents are making decisions.
That's what we aim for here on the Deep Dive, to spark your curiosity and equip you with knowledge you can apply to your own life and understanding of the world around you.
Speaking of applying knowledge, I am eager to dive even deeper into some of these specific search algorithms. I have a feeling we're about to get even more practical in the next part of our deep dive.
Indeed, we are. We'll be taking a closer look at breadth-first search and exploring how it's used to solve real-world problems.
Welcome back to the deep dive. We've been exploring AI agents and how they use search algorithms to navigate complex problems, kind of like peeking behind the curtain to see the thinking process of a machine.
It is quite remarkable. And today we're going to zoom in on one specific search algorithm that, despite its simplicity, plays a huge role in many AI applications, breadth-first search, or BFS.
BFS back for round 3. Now, if I remember correctly, this is the algorithm that systematically explores every possibility level by level without any prior knowledge of the environment.
Right.
It's like searching for the exit in a maze by methodically checking every path at each level before moving outward.
That's a great way to put it. BFS is all about thoroughness and exploring every option at a given depth before moving on. And this systematic approach, as simple as it sounds, makes it incredibly useful in a wide range of real-world applications.
So we've already talked about how BFS can be used to find the shortest path between people in a social network and how GPS navigation systems use it to calculate routes. What other real-world problems can BFS help solve?
Let's think about something that's becoming increasingly common. Robots working in warehouses or factories. These robots often need to navigate complex environments, moving around obstacles and finding the most efficient paths to retrieve items or complete tasks.
So in this case, the warehouse or factory floor becomes the maze, and the robot is using BFS to find the best way to get from point A to point B.
Exactly. BFS is a great tool for robot navigation because it guarantees finding the shortest path in an unweighted environment where each step has the same cost.
That makes sense. So if the robot needs to move from one end of the warehouse to the other, BFS will ensure it takes the fewest steps possible, saving time and energy.
Precisely. And this efficiency is crucial in real-world settings where robots need to operate quickly and reliably.
This is so cool. It's like BFS is the robot's internal compass guiding it through a complex world. It's amazing to see how a relatively simple algorithm can have such a big impact.
It really speaks to the power of computational thinking and how breaking down a problem into smaller, more manageable steps can lead to elegant and effective solutions.
So we've got robots navigating warehouses, GPS systems finding the quickest routes, and even social networks using BFS to connect people. Are there any other surprising applications of BFS?
Let's take a look at something we use every day, search engines. You know, when you type a search query into Google, it seems to magically pull up millions of relevant web pages in a fraction of a second? Well, BFS plays a key role in that process.
Wait, really? How does BFS help a search engine find information on the internet?
The internet is a massive network of web pages all linked together, kind of like a giant interconnected maze. Search engines use something called web crawlers to explore this network and index web pages, and guess what? These web crawlers often use BFS to systematically explore the web following links from page to page.
So the search engine starts at a specific web page and then uses BFS to explore all the links on that page, then all the links on those pages, and so on, until it has mapped out a huge portion of the web.
Exactly. It's like a digital explorer using BFS to chart the vast territory of the internet. And this process is happening constantly, ensuring that search engines have an up-to-date map of the web so they can quickly deliver relevant search results to you.
This is blowing my mind. I never realized how much BFS is working behind the scenes, powering so many aspects of our digital lives, from GPS navigation to robots to search engines. It's everywhere.
It really underscores how fundamental these search algorithms are to the way AI systems operate and solve problems. And as AI continues to evolve and become even more integrated into our lives, understanding these underlying principles will be increasingly important.
I completely agree. We've covered so much ground today, from the basic concepts of AI agents and search algorithms to real-world applications that are shaping our world in profound ways. It's been an incredible journey of discovery.
It has been a pleasure to dive deep into this topic with you, and I hope our listeners have enjoyed exploring the fascinating world of AI search and the power of BFS.
Absolutely. We hope you'll join us next time for another deep dive into a new and exciting topic. Until then, keep exploring and stay curious.